ready to load logs? Are you ready to load logs, over?
Yes, we are ready to loading logs.
Alright, that means we are go for loading logs. We'll open the logs vent valve. Stand by.
Welcome to the online streaming from Copenhagen Suborbitals today.
Thank you.
We are
Logs, you are
testing
go for
a new Gimbal
tanking.
engine,
We need 29
and
liters of logs, over.
it's nice weather, a bit chilly, but it seems to be a good day for testing. So I'll be back in a moment.
We see a pressure increase, 3 bar in the log tank, over. .6 bar, over.
All stations, the live stream is now active.
Alright, Rune, we have 3.2 bar.
I am Jørgen
17
Skødt,
liters,
and
over.
we are sending this from Copenhagen Suborbitals.
Okay.
Today we are testing a Gimbal engine made by our intern Job Nienhuis. It's the first time we tried to actually test a gimbal system. We are used to use jet vanes, and this time Job has made a complete system for gimbal control of the BPM5 engine. With help from Bosch Rexroth, he has designed and constructed a very compressed system that would match into a rocket like the Nexus 1 or Nexus 2, and we are very interested in to see how it will perform. And actually we are a bit delayed with the streaming here, so we are far into the checklist, and I'll be back in a moment telling you how far we are from a firing. It seems to be within 15 to 30 minutes.
Is it stabilizing?
I'll be back in a short
So we
time.
have 3 bars in the tank, currently 23 liters, dropping slightly, over.
But it's not fluctuating?
It's not fluctuating, logs level is just going down, so we're just evaporating logs, cooling the tank down. So let's just continue for a minute or two, over.
So let's continue cooling for a minute or two, and then we'll recommence log loading, over.
Exactly. Yeah, only we're down to 1 bar and 18.5 liter. Over.
Okay, let's continue loading then.
Yes, you open, and then we aim for 29 to 30 liters. Over.
All open now.
All stations, all stations, all stations. Firing is imminent. We have firing in about 5 to 7 minutes. 5 to 7 minutes.
Only we're at 25 liters.
25, okay. Thank you.
Only we just passed 29 liters. I say we stop here. Over.
Okay, I'll close now. Next line closed.
Let's just wait here for a short while. Over.
Do that, yes.
All right, only we'll take it here. You can disconnect. Over.
Okay. Oxygen line vented.
All right, thank you. Then it's time for a camera startup. Photo.
Photo.
Start high speed.
Well, as you have understood, I think we are rather far in the process. We are today streaming two channels. We have a main picture, and then we have a mosaic picture.
Go photo.
And I think they are starting the cameras right
All
now,
right.
so it can't be far from the firing. I'll return when I know exactly where we are in the check plan.
All right, Pyro, you're going for arming the igniter circuit. I'll commence arming. Right flight Pyro.
Go Pyro.
Pyro is armed.
Confirming from the panel.
Alright, Pyro, can you confirm the pad is evacuated? Over. Pad is evacuated. Alright, stand by all stations. Pressurization is imminent. This is a DPR burn. Ready for go no go. Crowd Alpha, go no go.
Go.
Stop. Go. Water. Water is go. Go.
Water is go.
Pyro. Pyro is go. Let's go. Alright. Alright, so everything is ready. Alright, we are ready to pressurize the tanks. We'll pressurize the fuel tank first. Go for pressurization. Fuel tank going up, 10 bars. 17, 18, 19. Fuel tank at nominal pressure, pressurizing LOX tank.
Well, it seems we are so far in the process that we will have a firing within maybe 1 minute. So stay on the channel and look forward for a nice burn.
Alright, auto sequence start in 5, 4, 3, 2, 1, 0.
T minus 20. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Base tanks.
We want to see a big smooch on it.
Oh, but did you see it? It was rock solid.
Yeah, you know, we could feel the heat directly down there. Wow!
Where did that come?
Actually, the distance.
Yeah, this was one of the. Oh, this one was also loose.
Yeah, I couldn't ride it more than
But the oscillation, we were really afraid about this play.
Yeah, but
Man, look, that's so stable.
Oh my God, dude.
Yeah, we were right. It didn't
It was so stable.
Yeah.
Så kunne jeg se direkte på
Oh my God, guys, that was so cool. That goes in the history books.
Guys,
What's the plan? But that certainly works.
Yeah,
God, it was cool. We were really afraid about the oscillation, but it seemed quite solid. I will check all the bolts. Yeah. And the joint as well. It's holding. I'm really curious to see the spike.
Even though it's
Yeah. This is. But look at the mylar. That's cool.
this one.
I see the watchstone. That's really cool because there's so much thermal mass in it. It's really big. It's basically
Now
big.
not considering the temperature of the, but it's fine.
Buskov! Did you see it? Oh man, it's amazing! Oh my God, I'm so happy. Oh yeah, fuck yeah, it's rock solid, everything's fine, nothing happened to it. The paint is gone, of course, but that's it. Oh man. I know, man, I know. Now we just need to build a bigger one, come on. Oh yeah, oh man.
Congratulations.
Oh yeah, but man, it was amazing. But oh no, that's fine. No worries. Thanks for your call. That's so cool, Morten. Thanks, man.
Oh yeah, that's why.
Okay. Oh, cool. Yeah, we'll do. I'll give the phone back to Mangen. Thanks, man. Okay. Bye bye. Oh, that was. Oh, yes.
Now they will let you go home, right?
It's
No, now we want to
yeah,
keep it.
it's just as hot as the other one. It's quite hot. But it's rock solid.
So did you use 3D broker pattern?
Yeah, we just had a sinusole pattern. It was the software is quite the control engineering was quite difficult on our public setup. That's what others can tell you all about it. You need to ramp up pressure because there's friction in the seals. You need to have 8 bars of pressure in the cylinder before it starts moving. So you need to build up pressure. Once you start moving, you ramp down, and then we can do an operating pattern. But it's man, there was. There's no play. Yeah, there's some play in the mechanism now. Probably some air is coming out. We need to deplete it before the second burn. But it seems to work fine.
The LOX line is
Yeah. The mylar looks good. The mylar looks good.
It's not freezing or anything.
But the engine is kind of hot.
So, bloody amazing.
Man, that was so cool. I can't wait to see the video where you just like. Yeah.
I can tell you that we got fried in the photo bunker.
Really?
You need to be down there watching because it looks so damn cool.
The second burn I'm gonna be there, of course.
Yeah.
That's,
What
Remember to have something to
Sorry?
spray
I think now it's at plus minus 2.5 degrees. Which is way too much for Nexa. Way too much. But, and the next one is going to be quicker, 30 millimeters a second. This was 20. We're now going to ramp up to 30 millimeters a second. It's going to go gook, 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 gook.
Let's see if Data and the flight agrees to put in a little bit more fuel as well.
I think I can handle it, but man, I need to check all the bolts though, I think, because the oscillation didn't seem that bad, but I need to check everything. This seems quite good.
Check all.
Yeah.
Check the connections to the electricity as well.
Yeah,
The wires.
yeah. Of course they will rattle loose. I have spring release on everything, but still I should check
but
it.
still after the burn, everything could be loose.
But man,
You've seen that so many times.
this is so worth it, you know.
Så skal jeg bare se, om jeg kan
I
ekstrahere
have
mig
to
selv.
go home. Bye bye.
Bye.
And you can take him with you.
But this one is fine. It's that was the main point. It's an aluminum joint up here. If that one would have filled, it would have flown out of the container. But that one is holding just fine. That's the main entire hinge of the entire system. This ring down here. And it's a sandwich structure of a steel plate and an aluminum flange with brass bushings, so it's self-lubricating. But my calculation said I had a safety factor of about 1.6. But if we have a hard start, so you have an induced thrust level, because of the combustion pressure. But I'm not sure what the thrust actually was. I haven't seen the data, but I guess it was normal with 5 kilonewtons.
I'm still looking at this computer.
Yeah.
We normally only have that number like 10 minutes later.
Yeah. Well, and Jakob said that he wants to put a 1-ton engine on it, so that's also a little bit in the design.
It sounded a bit like vibrations in the startup sequence. But
yeah, that's enough. And the problem is this tester is not designed for a gimbal. Come on. This steel plate, this flange here, it's not properly secured. So if you look at this, there's quite some plate, and that's not this thing. That's the plate down here.
Oh Jesus!
So that's
that's a very long arm on that small interface.
Yeah.
Oh man, that was cool. So optimally, the interface should be here, back there.
Yeah. But the hoses seem to hold as well. That's good. No leaks, I guess. That's okay. It's not too bad. But this footage is gonna be good for this.
I mean, we can just see, the dustbin kicked up.
Yeah.
From that angle, it's going to look absolutely amazing.
Og jeg skal med den der. De tænker bare på en kamera at the bottom.
There's a camera down there.
And there.
Yeah. And there's another one there, and there, and there. Oh. There's cameras everywhere.
Really advanced in technical cameras.
That was cool.
Each test unit, so.
I'm gonna get some tools and I'm gonna try the bolts.
We also need quite a bit of cameras.
Oh, definitely.
Yeah, more than just for better quality.
Maybe we should talk to GoPro.
Yeah, the GoPro, yes. And Sony. Sony?
Yeah,
because they also have very, very good action cams. Actually, I personally think that technically the Sony action cams are better than the GoPro.
Right. For image quality or just ruggedness?
Weight.
No, yes, I filmed it. Slow motion. I haven't seen that one.
Next picture comparison looks like Sony has a little bit better images. That's minor and is in the eye of the perspective.
What was the first level of the rejected porcupine, the one we saw? Was that
same?
Also fine.
Basically the same engine.
Yeah,
it's still BPM5.
it felt a lot more violent this time.
Maybe because of
Det lagde jeg ikke
the
mærke til.
Yeah, maybe.
Jeg kiggede længe, inden det virkede som, at det lige skulle gå ind til gå.
Can you run normal speed?
Maybe. I think
It looks good point where
was
awesome.
This one, oh, I'm pretty sure I have to hear it.
This one has.
This one. And that one, yeah. So, the pressure is also 300 bar after this main safety valve here, and then the proportional they can but we of course never have anything more like 25 out. It's always
Job, der fortjener det.
Ja, jeg synes, det er ikke kompagni.
It gives us all the flexibility we need.
Ja, men helt præcis, altså et af det er noget, vi står frem til. Men at lave det under de, noget der virker under de forhold, hvor der er vibrationer, der er varme, der er lydtryk og det hele.
Hvad har Bosch været med til at hjælpe? Jeg kender slet ikke deres...
I think that's
yeah, but it's still flexible. True. Which is way easier to handle than rigid switch pipes that you have to bend every time you want to change something.
Yes, but the pressure drop in the process across the manufacturer is getting higher than straight piping at the same diameter. The rule of thumb that you use better hoses for as short distances as humanly possible.
So det er derfor også, at det
we have done here. We only have 2 better hoses here. And the flow in that filling line is so low that the pressure drop doesn't matter.
Yeah, that's obviously because it's stationary. Actual test. Just feel this out.
Det er præcis det, jeg kom på.
Vi bruger 2 regulatorer på tryksystemet.
Det er ikke bare...
One for the fuel side and one for the oxidizer side.
Yeah, I know. Yeah, we were thinking using just one master regulator because we pressurize at the same level as both tanks and then using 2 valves.
True, but in the test that we want to operate at separate valves.
Oh, yeah.
So that's good.
On the road, just might need to add some
So in our case with the rockets, we have the pressurization offset. So that stays on the back.
Yeah, pressurization, but pressure regulation for the DPR system.
Ah, yeah, that stays on the back.
Should. You don't want to drag pipes down to the ground.
Don't get caught. That is a intermediate storage container for the nitrogen purposes. We have a silverite sitting here, and the outlet of that enters the fuel line just after the main line.
When you see the load cell, so it's perfectly following the load cell. There's a thrust misalignment on the top one, because well, we align it on the eye, of course, so it's actually facing upwards a little bit.
To purge every remaining piece of fuel in the engine, especially in the cooling jet.
Misalignment on that one.
Get that out, because otherwise it makes a fire.
3.5 cycles.
Yeah, we have about a liter of fuel left in the engine.
Yeah, I remember the big old fireball from last test.
That's
obviously the computer was a bit too slow. Maybe, don't know, but next time it will be better.
It comes from here and goes out through here and out into the pressurization container outside.
Okay,
we didn't destroy it.
This one.
No, because that one is right now.
It's still hot.
And this
It
one
is?
might be.
We can running awfully hot. How's the spray pattern of the inside?
Okay.
I think
That's normal.
Swap to nitrogen apparently last time.
I'm pretty sure we're running helium today.
Okay.
Should we paint it again?
No.
Basically just use nitrogen.
Sure, but
It was
yeah,
so wet.
even though this tank is quite big,
We should use heat
we
resistant.
still have to
Analyze it, right?
So if we get immediate for purge, some leaders will disappear again. So we just check we just get it in 2 seconds.
Next time we're going to be down there. Yeah.
Simple enough, right?
me? No, this is quite surprised. I haven't seen the footage for the second time, but it looks so rock solid. When you see when it's oscillating without the engine on, we have about a pressure in the cylinders of around 20 bars. Engine on, 28 bars. Nothing is happening to the cylinders. You just do what we're supposed to do.
I couldn't judge much from the photo because everything was shaking.
No, but
it looked calm.
It looked freaking solid. It's amazing.
The Bosch stuff, it held up quite good. I mean, we've seen things rattle apart before less.
Yeah. Well, it's far more torque, most of it.
Jeez.
But especially at this joint, this was my main concern, this part here. The aluminum joint with the bearings in there. But it is holding fine. I guess there will be some graphite dust falling out of it after this one. Yeah. Oh, it's...
And you have calculated.
Yeah.
And your extended Mylar insulated LOX line works fine.
Yeah.
How long was the burn? 15 seconds, I think.
15 seconds. Yeah.
I think flight decided to load it up quite a bit.
It was nothing fuel left. Nothing.
No,
Everything was used.
that's also why that's way hotter. Why is this engine going to be used a second time? Just do it.
Mere fuel.
Jeg har lige fyldt tanken op med benzin.
Så hælder vi noget på.
Men vi kan jo nok tanke op, at vi har en til.
Nu skal vi stå en længere kamera, så vi kører.
Det er spændende med det kamera.
Så lige tæt op nu. Jeg ved ikke, hvad der sker.
Nå, have det godt, vi ses.
Ja. Vi ses. Hej. Jeg kan godt se selve kabelvinklen, den kører. Måske kan jeg se, om der ligger noget. Det kan jeg ikke få adgang til. Hvad fanden der skete sidst? Siden af. Okay, var den også slået? Så den kan køre. Den er jeg spændt på. Er den stadig varm? Ja? Er den stadig varm?
Jeg var henne med på den før.
Han har fået blæst anden ikke af. Nå? Det er ikke noget. Ja. det virkede helt perfekt. Jeg ved ikke, om du har set det. Vi går lige bag om her, så kan du se igen. Nej. Det jeg tænker, det er at rulle helt ned på det, og sige, gerne den der. Hvorfor siger du, jeg skal gå den vej? Den vej, vi lige gået på her. Ja, der kører du tider, har du kun gået. Ja, og så læser du ind vej igen. Ja, jeg kan komme igennem klodserne der. Jeg kan komme helt på vejen.
Hvor mister Job?
Han er lige oppe i ham.
Nå.
Han skal op og have fat i noget internet. Han skal nok lære sig over, hvis han ender derhjemme.
Nå, jeg skulle have spurgt ham om, hvad spæksen er på dem der.
Det kan du spørge ham der Riksrådgud.
Nej, det ved han ikke.
Nå. Nej, det er ikke min masse, eller jeg ved ikke noget om den.
Okay.
Jeg vil bare gerne have dataen for dem. Fuck, det var smukt.
Wilson, Jørgen.
Jeg kommer nu, Jørgen.
Kunne du tage ham, Boschmanden, med eventuelt?
My name is Morten. I am the head logistics guy at Copenhagen Suborbitals. My job is to make sure that everything we need actually gets to Bornholm in the right time for launch. It's a multi-tier operation. We have some deliveries coming directly to Bornholm from, for example, the locks for the rocket, and some of it we bring ourselves on our ships. But mostly we actually take the biggest part by truck. It's easier. it's more reliable, and it's just easier than packing it on the ships. If you pack it on the ships, you need to make sure that it's weatherproof, where you can just rent a truck, put it in the back, and everything is good to go. When we get to Bornholm, we borrow some facilities where we can store it, especially if we have a delay because of weather or other things. And we usually have containers and stuff on the quayside to make sure that we can actually store things while we're working, because the Danish weather is well known for being very unstable, so we don't want delicate electronics being destroyed by rain just because there's a shower coming in. So that is basically my job, is to coordinate all these things and make sure that everyone has what they need in the right moment. And it is a lot of administrative work and 10 minutes of usually very hard work to get everything over there. At the same time, I make sure that we get the rocket on to Sputnik. It takes a little bit of lifting equipment. Some of it we actually made ourselves. It's kind of specialized. It fits the rocket and the rail it's being transported on. We lift it down to Sputnik, and from there we can use a hoist to get it up onto the rail and get it secured. So getting all these things to come together, making sure we have the right equipment is also my job. Most of it is of course coordination, and then the rest of the guys help with the actual doing of the job. So that is actually my main responsibility during a launch, and my secondary responsibility is a bit of photography, but that is usually done from one of the rib boats at sea.
Than the camera, do you think?
The next one launch is the first time we have an opportunity to see how our own CS2ino computer variant of the Arduino system is behaving in a launching rocket. We have developed our own version mainly because we need a mechanically more stable version, more rugged version than the original Arduino. And I for one am very anxious to see if our efforts will pay off and it will behave as we expect. We have 4 Arduino computers in the rocket. We have one in the engine controller in the base end of the rocket. We have one in the guidance and navigation system, and we have 2 CS2inos in the radio system to have redundancy in the telemetry system. For the engine controller, we have made an interface board that caters for the specific interfaces we need in the engine controller for the various pressure sensors, temperature sensors, and to drive the actuators and solenoids throughout the rocket and the engine compartment. To charge the batteries inside the rocket, we have opted for using a couple of commercial off-the-shelf ready-made chargers that we have put in our flight case, and so we can both charge the batteries in the workshop and in the harbor, and also at sea at the launch platform.
So we are back now. My name is Mads Wilson, and we are back from the little pause. Right now in the test area, the guys are setting up for today's second burn. We are going to burn the engine one more time and test the gimbal setup. And I have with me today here Kasper from Bosch Rexroth, who is the sponsor of this test. And Kasper, can you tell us a little bit about the setup of the gimbal and how everything has been constructed and Bosch Rexroth's role in all this?
Well, the actual mechanical setup is not something we have done. That is Job who has done that. But what happened was basically that we found the project to be so interesting and on the verge of what many people think is possible. So it's intriguing to be part of it. And in this case, Job was building this gimbal system, and for something the size of this, normally you would use electromechanical actuators. Yes. But in this case, Job wanted to try out hydraulics as a technology demonstrator for possibly bigger systems later on. So that's what we do. And we found that to be so interesting that we wanted to do this in the spirit of Copenhagen Suborbitals. So it's easy to design a system for something like this where it's not moving and everything would be fantastic, but we also wanted to have in mind that possibly it has to fly. So what we did was we tried to use the cheapest components in our catalog and put together a electro-hydraulic axis that is completely enclosed. There's no reservoir. The whole thing is pressurized. And that means we can basically move the axis in whatever direction it's facing, no matter what way the gravity is pointing. It doesn't matter to us. And we are also independent of the outside pressure.
Okay.
So that's the whole idea of the system. So for us, it's also experimental.
Okay.
The hydraulic consists of each axis has a pump and a manifold, a DC motor. In this manifold there are some check valves and some orifices to handle the flows. Then we have a symmetric cylinder, and we have a valve in front of the cylinders just for this test, because we were not sure how big of a shock we will see when it goes pre-stage to main stage, so we want to make sure we lock the cylinder.
Yeah.
And that's basically what we have here. So we control this whole thing by controlling it a PWM signal.
Okay.
More or less.
Yeah. And we, as you out there hopefully saw a moment ago, we have had a beautiful test. And we have also had a chance to look a little bit at the data, and maybe you could also comment a little bit on that, Kasper. What did you see in the data that we recorded for this today's first test?
Well, what I looked at was the data we picked up from the hydraulic sensors and from our cylinder, and when we compare that to the data we have picked up when we do testing in the workshop, it's completely nominal. Everything is as expected. We were afraid of vibrations. We were afraid of oscillations translating into the hydraulic system. We see nothing of that.
Okay.
It is rock stable.
That's fantastic.
It looks really, really good.
Yeah.
For a first prototype of this.
Yeah. Okay. That's amazing. And I mean, from Copenhagen Suborbitals' point of view, we are of course very happy to have Bosch Rexroth as a sponsor on this project. This gimbal that we're testing today is an experimental setup. As it is now, it's not meant to fly on any rocket, but this is a technology demonstrator to see and to gain some experience on handling a gimbal system for a rocket engine. Because when we move later on to our big rocket, the Speaker class, which will have a 100 kilonewton engine, we need to have a gimbal system for that. So you can say from our perspective, this project is it is very fantastic that we have had so good results so far, because this is our first step towards designing a gimbal system for the Speaker and BPM100 engine. So we will hopefully be doing a lot more of these kind of tests in the future, and I of course hope that Bosch Rexroth will be with us all the way. I think it have been a very fantastic test today. don't know the exact timing. I know the guys are working down there, but I expect that we, the next half hour or so, will be ready to perform the second burn of today, and that burn will probably be a little bit longer, so that we can fire the engine and be able to record some more full swing movements of the gimbal system. And I look very much forward to that. But again, Kasper, thank you for being here today, and let's cross our fingers that the next test will be successful also.
Yeah, it has been a pleasure. It was both arms in the air when we saw the nominal data came in, and the burn was as expected. So we're very happy, and we're very happy to see the hydraulics performing as we expect as well.
Okay. Yeah, but let's hope that everything also goes well in the next burn. And for all you audience out there, as I said, within the next half hour or so, we will perform a second burn on the gimbal system. So so stay tuned.
We have a question on the gimbal angle.
And we have a question coming in from one of our viewers regarding the angle of the gimbal system. How much can the angle vary from side to side in the gimbal system?
Well, actually, from my point of view, I don't know the angle. But what I do is I move my cylinders in and out. So I have 17.5 millimeters in both directions. I can move my cylinders. How that exactly translates through the kinematics is something Job knows. The angle is much wider than would normally be expected on a gimbal system. We are not too concerned about that since it's a technology demonstrator. There's no question if we move the cylinder further up, we will get a, let's call it, higher resolutions at lower angles, so we can control it much more precisely at those angles. But for demonstrating that this is possible with very cheap components, this is perfect.
Yeah. And I know from a flight point of view, we don't need a very wide swing of the engine. But of course, when you do a test setup like this, you push your equipment to the limits to see what it potentially can handle. Peter, do we have any more questions coming in from the audience?
No, how fast is it?
Yeah, we have a question from one of our viewers asking how fast the gimbal is moving from side to side.
Well, we ran the cylinders. Again, I'm focused on the cylinders here. So we ran the cylinders at 20 millimeters per second. It was a closed loop speed control, so we swiveled back and forth, closed loop speed control on this. There's a lot more going on to it, but that was the main task for us. So this first burn was 20 millimeters per second in either direction.
And will the next burn also be 20 millimeters, or will it be faster than that?
I'm not certain. I know Job wants to go 30 millimeters per second.
Okay.
We can do that, no problem. I just need a confirmation from him.
Okay, okay. But let's see, and of course, all you out there, we will keep you updated on when the next burn will be. But please stay tuned, and hopefully we have another beautiful burn video for you shortly.
Well, we have a new man in the studio. It's Job himself. He has got his arms down and has entered the OB1 internet studio here. And
Hi everyone.
And I would like to ask you, Job, as it happened, how do you feel right now? It's your bachelor project, and
It's I've never been so excited about any project I've done so far. It's you start here in February, you know.
Yeah.
You start here in February, and now I don't want to know how many months later. Finally, you have the result.
Yeah.
Seeing it work, everything is nominal. It's wow. It's such an adrenaline rush.
Yeah.
It's
You have done a lot of it by yourself, but you have had a lot of help from Bosch Rexroth.
Yeah. The way it was set up, initially I was working on a design for an electric gimbal system.
Yeah.
As we now know, this is an hydraulic gimbal system. We got contacted by Casper, who has been here for this early interview, and he's a real fan of Copenhagen Suborbitals, and he got out to us and he said maybe we can do some sponsorship. And well, what would be a better way to do that than to make an hydraulic gimbal system, just like the big guys like NASA and ESA. So I sat down and I gave the preliminary design of the cylinders I wanted to have. I wanted to have a simple pump unit with some check valves and a cylinder. And Casper and Tommy, two engineers of Bosch, they sat down and they made the proper design, the final design you will see here on the footage.
Yeah.
But all the input was given from me for load, speeds, form factor a little bit. But it's the system we have right now. It's the smallest operational EHA system, electro-hydraulic actuators, built by Bosch Rexroth.
Ooh, that's really interesting. It's very compact.
Yeah.
I find it very compact. Have you, as a bachelor from Holland, do you feel this will have some importance for you in your studies?
It's
in Holland.
I guess so. The beautiful thing about CS is that you're able to come here as an intern, and well, if you want to do a purely theoretical report, it's fine. But you're given the freedom to build your own rocket engine, to build a gimbal. They support you in any way possible, and that's also when I do a project, I value the physical realization quite a lot. It aids quite a lot to the final magnitude of the project. If you make a design on paper or in SolidWorks, it doesn't really say that much about your skills as an engineer.
No, but the funny thing about this is I'm not used to bachelors making so much mechanical engineering in their project. It seems very big. Is it common for Dutch engineering students to build so huge machinery just for a bachelor?
Not that I know of, but well, as you know as well, I like to build stuff and to weld, and that's why maybe I've gone a little bit out of the scope for a normal bachelor. It has taken me almost twice as long. That has to be added as well. So but it's not that common, especially for my study. We don't even get we don't even get machining courses or welding courses.
Okay.
It's because I've been working from quite a young age with metal and big machinery that I'm quite able to do this. But no, it's not that common in Holland to do.
But when you look at this machinery on this, can we have another picture up from camera 3 maybe? Yeah, when we look at this picture here of your perfectly working engine, it has a lot of colors on it. It seems like you have gone the designer way too a bit.
No.
You couldn't. What's it about this green? It's slightly green color.
Like most people in CS already know, I'm a really big fan of Russian rockets, and the Russian design approach is the only way to go. I don't like white and black American rockets. The Russians have a tendency to use, as they call, cheap pastel colors for their rockets. So it's a mint, vomit green, but it's the perfect shade of green for rocket
The
engines.
perfect shade of green.
Yes,
so it's kind of a
yes.
tribute to Russian.
That's the same if you look
rockets
before the burn. The nozzle was painted red. And
Yes,
that's also a
it
Russian
was.
tradition.
Okay.
It shows the hot end of a rocket engine.
That's almost like what could you call it? Cargo cult over it. Well,
Yeah.
the Russians have painted
Yeah.
their things red inside
Yeah.
the nozzle, and so you painted red
Yes.
too.
Because I want to look at it's supposed to look like a small Russian rocket engine.
Okay.
I want to take pictures of it and put a black and white film grain on it and then post it on Russian rocketry forums. Like, look what I found in my attic.
Yeah.
That's
But still, you're not using Cyrillic in.
No. But it's there's quite some room for optimization in the design. There were some minor additions made in later stage of the design, including some check valves on the hydraulic
Yeah,
system. So the system is a bit bigger at the moment than it was originally intended to be, but it's a good technology demonstrator at the moment.
Now we have seen some of the earlier engines. This engine has been tested a few weeks ago, just to make sure that it didn't explode, and it didn't. It was perfect. I think it delivered 5.5 kilonewtons perfectly through all the burn.
Yeah.
And I have just a tiny question about the fuel line. It is changed. It doesn't look like the other ones. What's the difference between this and the other ones? You have changed it.
Yeah, it used to be a round fuel flange, round fuel pipe, but I had a little bit of artistic freedom, and I like oval shapes. So it's an oval fuel pipe, and well, actually there's some reasoning behind the design of this. There's an aerodynamic fairing could be placed around the gimbal system. So if it were to fly on a rocket, it could have a fairing around it, so it would be more aerodynamic.
Yeah.
To then further decrease the footprint of the rocket engine by using an oval tube, the overall surface area or the diameter of the rocket engine would be a little bit smaller.
Okay, but now I hear that you are actually needed up at the test stand. So we have to postpone this interview, and thank you.
Thanks for
the time.
Yes, I'll be back.
Yes.
Jakob, this is Job. Yeah, go Job. I'm on my way back. Sorry, I was in an interview. You needed to be there, but we're waiting for you.
No need to apologize. The PR department needs to get people to do interviews.
Well, Job had to rush to the test stand again. There was a need for his help up there. We are preparing for a second burn. The first one was only 15 seconds with a very nominal performance and perfect data. And there is a rumor that we will try to reach maybe 30 seconds of burn. That would be tremendous, but let's see what's going on up there.
back to Copenhagen Suborbitals. It's Easter here in the rocket shop, so we're pretty busy. I have something here which is hardly recognizable, but this is the BPM5 engine we have been following so far. Inside here is actually the soldered inner liner that we started out with a long time ago. Now, today it looks way more like a rocket engine, and we've actually made pretty good progress here. This is still our very first BPM5 engine, so we have a lot of things we are learning in the process of assembling it. So it's still taking a little bit longer time than necessary, and the results needs a little more adjustment. But we're getting to a rocket engine when we're done. We've been quite busy here. This flange, which will carry the injector, the filters, and the entire LOX dome, has already been welded in place. Both the inner liner and the outer liner, everything is welded in place here. Now, the outer liner was cut up in 4 pieces, 2 cylindrical half parts and 2 bell-shaped half parts. What I did first of all was weld together the 2 cylindrical parts. I could just pry open this last crack here, and it would easily slide on and off the copper spaces. Now, due to a few production mishaps, we have a little bit more of a crack down here in the bell shape. I simply cut out a few pieces of material that I will insert, which will largely just close this crack up, and then I'll just weld it on the outside. Now, the entire fuel manifold has also been welded in place. I still need to trim the edges down here so that we can make a nice sharp edge to release the supersonic flow out of the engine. The fuel pipe, or the beginning of it, is already in place here as well, and this is where we'll put approximately 2 liters of alcohol through per second. So all that's left to do here really is to close up this long stem here, and I already have a piece of material which I'll simply just stick here on the outside and then just weld it in place on either side. Now, it's a little bit, so to say, risky to do a welding of this long stem without additional material. I could try to do that, but in order for this outer liner to be able to cope with the fuel pressure we're putting into it, at some point probably 25 bar, I need to be sure that I get a welding which goes all the way through the material. Now, that carries a risk that I actually heat it too much, and then I'll have bubbles and blisters and protrusions on the inside, where we right now have this rather smooth 2 millimeter thick channel which carries all the fuel from the fuel manifold down here below all the way up to the injector and cools the entire engine on the way. Now, if I just weld it and weld it a little too much, then we will simply have some disruptions along the fuel flow along this line, which could mean that we will get a few hot spots down here, and we don't want that for our first try. So progress on the BPM5 is progressing fast. We are learning a lot as we go along. This is a brand new engine design, and naturally we have already found a number of ways to refine and improve it, so we can just make it much easier to produce. So well, we're learning a lot here and making a lot of first experiences, and we're getting a hopefully fully functional BPM5 rocket engine as a bonus.
solen begynder at forsvinde.
As you see right now, the test stand has been empty for people. We are preparing for a new burn, and maybe, as the ruler says, a longer burn. And I will return when I know exactly where we are in the check plan.
Både svejsningerne. Nej, det er en forkøling, der hedder kommet glemme.
Dansefyrer i 2 dage.
Det er alarmsirenen.
Nu 2 friske fyre, det er ikke til at blive færdige.
Alright, all stations, we will commence and prepare for the next test. All stations, ready?
Testen her, Jørgen.
Klager de over en lyd.
Svarer du ikke ind?
Næste. Bare til jeres orientering, vi har altså lyd på fra teststanden, så da I står og hopper og danser med deroppe, det kommer ud. De hoppede ikke. Gøgergokke er færdig. Takker.
Vores tilstand, vi gør, hvad vi har lyst til. Når vi har lyst til.
Alright, everybody, we start checklist from item 36. Confirm igniter circuit is software disarmed. Confirm. Power flight. Pyro flight.
As you can hear on the stream, we are preparing to install the pyrotechnician. The pyro, and the pyrotechnician will come and install it, and then we will, after that, we will commence the fueling process.
Pyro, can you confirm igniter circuit is hardware disarmed? Over. Igniter disarmed. Alright, then you are go for installing and connecting pyro. Report when completed. Over. Roger.
Joke about how you could drive a truck with your arms over your head until we figured out that you wasn't driving.
Oh my god, yeah. It also looks good, by the way. Still looks good. Yeah. Even after. I want videos now. I want to see the video.
I went back and I watched the live stream again and rewinded it. It's even at the end, you couldn't really see because the screen cap is not that good, but I think it's
yeah, it really looks.
And it's tracking quite well.
Photo, Bianca.
We have a decent tracking.
Are you coming to the bunker?
Yes. Right now I'm 1 minute away.
Smørstue. Smørfestue. Smørfestue. Cykelkugle. Cykelkugle. It's like the Wilson stick and the mic stand. Yeah.
And the Jürgen sleigh.
I don't want anything to do with the Wilson stick.
The Wilson stick? Now you're in the way for the camera.
Yeah.
With the camera. What about your Australian?
Yeah, it was supposed to be here, but he said it would also be headed for Berlin. Might be the right time. But my girlfriend, she's spoken a text message on WhatsApp, screaming.
She's watching the live or something?
Vi har containerfyldt af en masse folk, der ikke vil være der, når flyve er der. Okay, det kigger vi på. Booster, har I ekstra personal i containeret? Det kan godt, ikke?
I hit somebody in the face.
Kommet op på noget?
Nej.
Er det det, der gjorde det?
Right now you see from the test stand the installation of the pyrotechnical device. It's actually a kind of New Year's Eve fountain, not very powerful, but it delivers a lot of metal sparks that has a temperature that makes it possible to ignite the fuel and LOX mix. Right now it is disarmed by software and by hardware. We have a shunt that makes it impossible for the pyro to get blown off. And it will not be armed before the test stand has been completely cleared for people.
Booster, do you have any unnecessary personnel on the pad, over? No. Alright. Alright, Booster, step 48, are you go for LOX loading, over?
We'll go for LOX loading.
Alright, then we are go for LOX loading. Data, open the vent valve.
LOX vent is open.
Alright, Booster, you are go for loading LOX. Target is 28 liters, over.
Okay, commencing LOX loading.
Fly photo. Go photo.
Get on.
Thanks. We have 3 bars in the LOX tank, over.
And how many liters?
Not registering yet, over.
Okay.
Carsten Jørgen.
Carsten, ja.
På billederne her, hvor vi sender ud, der står du direkte foran en raketmotor, og der er ved at blive tryksat.
Hvad er ved at blive LOX påfyldt?
Ja, men bare lige det billeder.
Yeah, Rune, I think we're hitting the LOX sensor. We're seeing some increase now.
Okay, thank you very much.
Yeah, so we're at 1.1 bar and 15 liter. $20 liters. $23. $25.
Do a hold here and see how it settles.
Roger.
Flight logs here.
Go logs.
What is it saying at the moment?
24 liters, 0.6 bar.
Okay, I'll commence loading then.
Roger.
We are almost have almost finished loading logs, and after that we will arm the igniter. There will come a shot in a very few minutes. Stay tuned.
We're at 28 liters, so we will just give it 1 liter or 2 more, over.
Okay, thank you.
All right, we're at 30. Stop here, please.
Locks closed. Locks fill line vented.
Thank you. You can disconnect.
Select.
The tanks are fully loaded with logs and fuel. It will be a long burn, this.
All right, all stations, we are about to go. Photo flight.
Photo.
You're a go for high-speed camera start.
Crowd Jakob.
Gentag.
Crowd Alpha, Jakob.
Crowd Alpha, kom ind.
Bagerst enden af skydeområdet er sikret. Skift.
Det er forstået.
Fly photo.
Go photo.
We are done.
Tak for det. Pyro, flight.
Pyro here.
We're at step 52. I'll go for for arming the igniter circuit hardware.
All commence with arming.
Now all the cameras has been started, and the pyro will be armed. So there's a very short time before pressurization and firing. It's gonna be very interesting, because this engine has never been tried for so many seconds. I think we have run it for 10 or 15 seconds at the most, and this time 25 or 30 seconds duration will be seen.
Pyro, step 53, can you confirm the pad is clear? Again, over.
Pad is clear.
All right, everybody, This means pressurization is imminent. This is a DPR burn. Ready for go, no go. Crowd alpha, go, no go. Go. Booster. Booster, go. Water. Water is go. Photo. Photo, go. Pyro. Pyro is go. Data.
Data is go.
Alright, we have green board. We'll commence with pressurization. We will commence pressurization of the fuel tank. Fuel tank pressure 10 bar.
As
18
you
bar.
see, during the pressurization, there's no people on the test stand or nearby.
Fuel target is
because now
28.3
it is
bar.
going to be a bit dangerous to be near, and we will see some action
Fuel
soon.
tank at 20 bar.
We will see the longest burn ever for this kind of motor, so be prepared.
20.5. 21. 21.3 will commence LOX tank pressurization. LOX target 20.7 bar. We're at 12 bar. $19 bar. LOX tanked 19.7. LOX tank 20.4. All right, all tanks pressurized. We will commence auto sequence start in 5, 4, 3, 2, 1, go.
T minus 25. T minus 20. 15. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Take safe.
Bending fuel tank. All right, boosters, we're at 3 bars. You can approach.
Booster, both tanks are below 0.5 bar now. Okay, the test stand is open for photo people only.
Photo, please shut down cameras.
Seems like a nominal burn, but a bit shorter than
Photo will go in.
expected. We will just in a short time tell you why. There was a question on the chat concerning why it looked like it was burning and then it shut down and then there was a short burn again. That's actually a nitrogen purge, as we call it. We are emptying out the whole system for fuel by pumping nitrogen through the fuel line. That's why there can come a short burst of flames after
vi er færdige.
You might wonder what all these people are doing around a rocket that is
standing there, you know,
with so high power. But actually, the system is passive, completely passive. There's no pressure anywhere in the system, so there's no danger in closing up on this gadget.
But the thermal capacity of the lugs of this one is so big. It's just that looks so cool. No leaks this time? Nothing? No? Oh man, it's standing.
Yeah.
Nice warm wind.
Seeing it move. Oh.
It's beautiful, man.
How far did it hit the container?
No. I think it might. How warm is it?
Yeah, I tried to catch it, but it's cold.
I don't think it really impinged on it. I don't think so.
I think it's, yeah, it does. Almost, but not completely.
We didn't check. It was fine.
It was fine, that's true. It's still here, everything's fine. So, it's working.
Let's see, I want to see if you can see hot spots.
Is your face?
So you work?
You can't see any of the dots. It's
Scott.
It's mainly the triple spray pattern.
Ja. Hej, der er ikke sådan en kører igen.
But you can see the heat waves.
Så skulle de være slukket.
That's a lot. Yeah, look aside.
Der var ikke noget svært. Ja, okay.
There was a question on the chat asking whether this gimbal only works in one axis or we just haven't tested the other axis. Actually, there's a problem when you test both axes at the same time with this contraption lying down. It's horizontal oriented right now, and it is designed to be upright. So tests has showed that if we try to test the up-down gimbal function right in this setup, we could risk that the engine would slowly sink to the ground and pointing directly to the floor. So we are only testing the horizontal axis right now. Well, this was the end of the hot action of today. We have had two tests, a short test and a longer duration test with the Job Nienhus gimbal system. There's a lot of talk right now outside the test stand, I see, and the people down there are preparing to clean up. But we will keep the stream for some minutes. I don't know how long, but maybe we can have an interview and see how good the data was from this burn. I'll be back.
Talk to my girlfriend. She was screaming in the air. She looked to the line, please. Oh, it was amazing.
Men det er lidt nemmere at gøre det, når de har nok.
But it worked beautifully.
Faktisk komme til at arbejde ved siden af.
Sadly, we couldn't do vertical. We had a problem with the check valves in here. It doesn't blade on it. So when you so when you test it vertical, it's fine, but not in horizontal. So we could do both, but we don't.
No, der er but it's the same system. Der er ventilsystem horizontal and vertical, right?
Yeah, it's not exactly the same setup. It's just because the weight of the engine is not creating a pressure in here.
Which strips the check valve.
Okay.
Yeah,
so that's why pro guys who have to Gimbal don't test horizontal. They test vertical.
Okay.
But this is good to get data for the load cell. That's really good.
I'm Scott.
That's awesome. Oh yeah, congratulations. I want it back in the workshop.
Jeg har taget den af. Så kan vi tage... Jeg begynder at rydde...
Vi slet ikke gøre det, eller er det bare, vi gør det om lidt? Vi gør det slet ikke. Okay.
Well, this seems to be the end of this day's static test of 2 engine burns. We are preparing to close down the cameras and stop the streaming, and we will thank you, all you viewers, for following us. See you next time.
Mask, Jacob.
What do you need?
Mask, Jacob. Mask, Ken. Mask, sender du lige en servicemeddelelse ud, når streamfolkene kan begynde at pille ned og skifte?
Vi lukker ned om 3 minutter.
Er det et ja?
Det er affirmative.
Mange tak.
Der var